Okay, we're back with a correction. When I put this point 1, 2 into the transformation, I got the point 1, 1, and then I graphed 1, 0 accidentally. So it should have gone in there, and now I erased my other one. What was it? That's okay. Okay, there we go. So, could you state the domain and the range for that new function? Okay, the domain is easy. It's exponential. It's always all reals. The range, well, because of the reflection, it's y less than 3, that horizontal asymptote, which on our graph we probably should have labeled. Okay, the other key feature of this graph is you ought to be able to label your intercepts. And I can see I got 1 right there. When x is when x is 0, I've got y is 2. What's my x-intercept? So there's my y-intercept. How do you find an x-intercept? Well, to find an x-intercept, you always let y equal 0 and solve for x. So here's a good review of algebra. I would be solving this. 0 is equal to 3 minus 2 to the x. We want to isolate the exponential. I'm going to add it to both sides. That is 2 to the power of x is equal to 3. When your variable is in the exponent, how do you solve that problem? You need a log, inverse of an exponential. So let's take the log of both sides. So the log of 2 to the x is equal to 3. How does that help me? Your power law for logs lets you know that x comes down in front. X times the log of 2 is equal to, oh my goodness, I took the log of 2 to the x, which means I did the same thing to the other side of the equation. Just a little spill. Okay, so x log 2 would equal log 3. Solving that for x, I get x is equal to the log of 3 over the log of 2. As in, to what power do I raise 2 in order to get 3? And that's a calculator question. You can plug that in and tell me what you get. 2 decimal places. It should be 1 point something. 1.58. Okay, so x 1.58 when y is 0.